Hi everyone, I wanted to do a quick video on electric fields because it's been ages since we talked about it last week in class, and we didn't do in-class practice, even for those of you that were in class. I want to say from the outset that electric fields are not a central concept on the AP exam. They do show up on the SAT2 and the Regents. My goal for this video is to make sure you kind of get a basic conceptual understanding of what electric field strength refers to and the direction and shape of electric fields for common configurations. So to start, I want to build on an analogy to gravity. I also want to say that whenever I ask a question like which mass experiences the most gravitational force, I will wait like 3 seconds and then proceed. If that's not enough time, please do take advantage of this video format and pause. Okay, so which mass experiences the most gravitational force? Hopefully it's not too hard. It's A, the universal force of gravity, G m1 m2 over r squared. It gets weaker the farther you are from the source mass. What about this one? Which location experiences the most gravitational force? I hope you pause with this question because it's kind of a weird question. And if you're thinking A, oh, the strength of gravity is sort of greatest at A, I want you to think about this scenario. There's a small mass at A and a large mass at B. And because there's a large mass at A, it might experience a greater gravitational force, even though sort of the strength of gravity is stronger near A. So we're running into a problem where the gravitational force depends on the mass that I put at that location. I can't put, I'll say this location, the gravitational force that a mass will experience here, it depends on the mass, whether it's a big one or a small one. So what do? Let's divide out the gravitational force. Let's divide it by the mass and look at the gravitational force per unit mass. And so equation-wise, that's what it looks like. Gm1 m2 over r squared, where m1, I'm going to call it the mass of the Earth. And what do you get? Gme over r squared. Does that look familiar? I hope it looks familiar. What is that? That is actually the gravitational field strength, little g. So that's what G describes. That's what little g describes, the gravitational field strength. It describes the strength of the force of gravity at a certain location, the newtons per kilogram. So what we're doing really by dividing out the mass is saying, hey, forget the masses that are there. What are, for any mass per unit kilogram, how many newtons of force would I experience? So 100 newtons per kilogram, 50 newtons per kilogram. Here on Earth, it's closer to 10 newtons per kilogram that you would experience, that any mass would experience. So that's kind of the basics with gravity. That's what gravitational field strength really describes. And now we can actually just build on that to think about what does that mean for the electric force. So instead of a giant mass, I have this source charge Q1. And where do you think the electric field is strongest? A or B? Hopefully it's not too hard. It's of course the same force per unit charge instead of per unit mass. So we're going to put in Coulomb's law there, KQ1, Q2 over R squared, where Q1 is this source charge over here. And what I'm getting is essentially the electric field strength for a point charge. Q1, I'm treating it like a point charge. So yeah, it is A, it's stronger. But I'm running into a problem. In what direction does the electric field point? It depends. If I put a positive charge at A, you'll see that it'll feel a force to the right. But if I put a negative charge there, it'll feel a force to the left. Opposite charges attract. So what do? I go with convention and define the direction of the electric field relative to what a positive test charge would experience. Just keep in mind, there is no positive test charge here. It's just I need to imagine if a positive test charge was there to kind of define the strength of the electric field at that point. Okay. And the size drops down. So if I'm representing this with an arrow, the farther away it is, the shorter it is. So just to recap, that is your definition kind of electric field strength. It's analogous to little g, gravitational field strength. The units are newtons per coulomb, and it is a vector. Key thing is it describes a location. To describe the force on something, you need to know what mass is at that location. But to describe the location itself, all you need is like the gravitational field strength. Okay. And then that's the equation for a point charge. It's not on the reference table. It is something that you would need to remember for the SAT too. And yeah. In summary, the electric field strength, it's what a positive test charge would feel if it's at that location. Key idea though, there is no actual test charge there. You're just imagining it. And those are the common representations. This is my electric fields video. Hopefully it was helpful. Work out the practice and check out the solutions. That should help cement the ideas a little bit. Take care.